Hello YouTube, and hello Honest Discussioner. I know I haven't included my normal intro for this video because I'm not intending this to be a big fancy episode. Just my thoughts on Honest Discussioner's latest video, one second latest video actually, as of this recording, Schrödinger's bomb. And there are several things I want to respond to. About the whole scenario that you're describing. First of all, I'm not a physicist, so I can't really be seen as any kind of authority on quantum mechanics. And furthermore, what I do know enough to know is that as some physicist, I think it may have been Richard Feynman, but whoever it is, I'll put their name in an annotation here after I look it up, said, if you think you understand quantum physics, then you don't understand quantum physics. So take everything that anyone says with a grain of salt, and take what I say in particular with a grain of salt, because I'm not a physicist at all. So, that being said, first of all, I have always found the Copenhagen interpretation to be unnecessarily mystical. It seems to me that what we're dealing with here has nothing to do with the metaphysical act of observation, and everything to do with the scale of the particles involved. Everything that we think of as the weirdness of quantum mechanics has to do with really two things: the results of the double slit experiment, which is where we get the idea of waveform collapse, and Heisenberg's uncertainty principle. Now, I'll start with... Oops, didn't mean to flip you off. I'll start with Heisenberg's uncertainty principle. We can only know either the position or the velocity of a particle, not both. Because to measure one is to affect the other. Sort of. It's very complicated. Well, there are varying degrees of accuracy with which we can measure both of them. You can. I don't know what knowing something halfway would be. I don't know how precise 100% is. But say we could 50% know its velocity and 50% know its position, and we can choose for whatever application we're doing this, how we want that equation to balance. The reason that that's the case is because it is impossible for us to construct a piece of equipment that could make any measurement on a smaller scale than the particles it uses to detect the change, which is usually, like, say, for example, an X-ray photon. We can shoot an X-ray photon at a particle, and based on the nature of that photon's return to our testing equipment, we can make observations about the particle that it hit. But we actually can't tell very much about it, because it's just one particle hitting one other particle. We can tell either how fast it was going or where it is. Exactly how that teases out, I'm not sure. Like I said, I'm not a physicist. I don't know the details. I don't know the math. And this has a lot to do. This now comes into play with the double slit experiment, which is the other aspect of this. Basically, the double slit experiment, you have two slits, and you fire, say, electrons or photons, for that matter, through it from an emitter at the double slit. And if there's let me see, how exactly does it work? Yes. Yes, if you simply emit the photons or electrons through the double slits, they will form an interference pattern like waves. Similar to if you throw two pebbles into a pond, the ripples, the waves will interact with one another and you'll get these bars of an interference pattern. On the other hand, if you set up a detector to intercept the particle, the electron or the photon, to detect it on its way through the slit, because there are really three possibilities for what the particle can do when it's passing through the double slit. That when it's interacting with the plane that has two slits, it can either go in the top slit or the bottom slit, or it can just hit some other part of the wall and not go through at all. Those are the only two options. Certainly, assuming we're dealing with particles. When there is no interference, they don't behave like particles; they behave like waves, as if sound waves were going through these double slits. But when we measure the particles, when we measure them on their way through, they do behave as particles. Like, for example, if we emit them, for example, one electron or one photon at a time, and we take the time to observe where it's interacting, which slit it's going through, every time, one at a time, then suddenly they start hitting these spots, and these spots form the bar, not the interference pattern. And just for clarity, if we send the particles through one at a time and we don't observe where they go first, they form an interference pattern. Now that seems very odd, and we're not sure why that is. Basically, it seems that the role of the observer interferes with whether this phenomenon expresses itself as a wave or a particle. But that's not quite right either. Or at least that's not a justified assumption based on the data. There's nothing about what we're observing in the double slit experiment that should tell us that it's the actual observer, the fact that there is a perception taking place. That's really not. That maybe. I mean, I'm not saying that's not possible. I'm in certainly no position to say the Copenhagen interpretation is wrong. And certainly this isn't, even if I were correct about saying this, it wouldn't necessarily mean the Copenhagen interpretation is wrong, because I'm probably not familiar enough with the basic assumptions of the Copenhagen interpretation to say that with any confidence, but it's certainly not justified to say that there's some metaphysical interaction caused by the observer is causing this to happen. We do not need to feel that our minds are causing this particle-wave duality. No. There is something physically happening to the particle in the process of observing it. It is being impacted by another particle. What they call this in discussing it, no matter what interpretation you choose, well, there's some. Any contemporary interpretation would refer to this as the waveform collapse. There is something that is interacting with the particle that's forcing it to, I guess, declare its intentions, to use an unfortunately metaphysical metaphor, about where its slit's going through, and from that point forward, we've kind of let the cat out of the bag in terms of where its potential, where it could go, how it might express. How the actual electron or photon travels through space while it's not being observed, we don't understand. We don't know the answer to that. And the double slit experiment has only shown us how little we know. It hasn't really explained anything. I guess it's brought us closer to the truth insofar as it's exposed our ignorance, but it's very confusing. But it doesn't necessarily follow that there's an observer, or an effect caused by the observation itself. Now, how does this apply to Schrödinger's bomb, which is, honest discussioner's alternative to Schrödinger's cat? Basically, what he says is that in Schrödinger's cat, the cat is simultaneously alive. And I'm not going to go bother explaining exactly what Schrödinger's cat is. If you haven't watched Honest Discussioner's video, he does explain it there, and you should have by now, and shame on you for watching a response without watching the video to which it is a response. Why anyone would be watching my channel and not watching Honest Discussioners, in my opinion, that's just a travesty in and of itself, but that's beside the point. In the particular interpretation of the Copenhagen interpretation that we're dealing with when we talk about Schrödinger's cat being simultaneously alive and dead until we open the box, thus collapsing the waveform, we could say that that's simply a different thing that's happening as opposed to Schrödinger's bomb. If we take Schrödinger's bomb, as you put it, then the force, the moment at which the bomb must either detonate or not detonate, that is the moment at which the waveform collapses. Like, let us say, just for the sake of argument, that we put a 2-minute timer on the bomb, that it's triggered by the presence or absence of radiation, but then there's a 2-minute delay, and it goes off at the end of that 2 minutes. There's a moment in the experiment where you know beforehand that either the bomb will be triggered at this moment or it will not be triggered, but it will be decided by this moment. And basically 2 minutes from that moment is when the waveform will collapse. And so if we assume for whatever reason that it's exactly 50-50, half of the time the bomb will go off and half of the time it won't. It won't go off all the time because the bomb is constantly in a state of both exploding and not exploding. If you take the interpretation that is being assumed in this reading of Schrödinger's cat and extend it to this Schrödinger's bomb, then you would say that the bomb is, that the timer is simultaneously in a state of counting and not counting until it gets to the end of its countdown, at which point the waveform collapses, and either the bomb explodes or it does not, and that will happen at whatever probability rate is established, and we're going with 50-50 for the sake of simplicity, if I understood Honest Discussioner's video correctly. Now, that's again, if you assume that the waveform is collapsed because of the effect of an observer. In actuality, the particle, well, see, I don't know how this applies to radioactive decay. This waveform collapse that we look at when we're talking about the double slit experiment. I don't know how those two things necessarily relate to one another. Oh, incidentally, followers of my channel who are noticing that that I'm wearing an Air Force shirt and have my hair short and am clean shaven all on the same day, these three things are all a strange coincidence. I got my hair cut the other day because I've been job hunting and wanted to look professional, and I didn't ask for it. And this actually probably isn't in military regs. I am not in the Air Force any longer and have not been since you started seeing me grow out facial hair and long hair. I just wore this because I got out of the shower and it was convenient, and I shaved this off because it was getting long and it made me look kind of like a goat, and I still want my female counterpart to find me attractive, so I just decided to shave it off. I am still a civilian, so breathe easy. Back to the point, however it is that waveform collapse in the double slit experiment and a waveform collapse in the decay of radioactive materials relate to one another, and this is my feeling as a non-physicist. I simply don't know how those two things relate. However it is that they do, we can, I feel comfortable saying there is no reason for us to assume it is the presence of an observer. So, my personal interpretation, and this is more of a working hypothesis than any kind of, there's no real strength of conviction here because, as I said, I'm not a physicist, but my attitude, I guess, would be, my perspective would be, there's no reason for us to assume that it's the actual opening of the box that collapses the wave function and either poisons or doesn't, or it either kills or spares the cat. And it's not the explosion of the bomb at the end of the timer that actually collapses the wave function and either detonates the bomb or does not. What what collapses the wave function is the interception of the particle by the transceiver, by the emitter. If we're assuming that, see, I don't know what the analog in terms of radioactive decay is of intercepting the particle in the double slit experiment would be. Because when you shoot the electron through the double slit, it's already a given that the electron is going to be fired, or the photon is going to be emitted, or what have you. That's a given. You're just wondering which way it's going. Whereas with radioactive decay, you're wondering whether or not it will happen at all. So I don't know how those two things would... I don't know where the analog is, but wherever that is, whatever that determining factor is, the point at which that is influenced by the actual particulate interaction, the actual physics that's actually happening on that scale, and that probably has something to do with the radiation detector. There is no reason, in my opinion, from my perspective, to actually think that the detonation of the bomb is the point. I'm saying if you were to carry the reasoning of Schrödinger's cat being simultaneously alive and dead into the same thought experiment, then you would say the collapse of the waveform comes when you open the box in Schrödinger's cat's case, and in this case would happen when the box either is detonated open or isn't, and at that moment, and it's still going to happen half the time if it's 50-50. It's going to happen according to the probabilities. Whereas, in my point of view, that's not actually, I don't think that's actually what collapses the waveform. And I guess what I'm saying is I don't know enough about what Schrödinger was trying to get across to say whether or not I agree with Schrödinger, but I would say I disagree in the first place with that interpretation of Schrödinger's cat, that the cat is alive or dead until you open the box. I think that at no point from my understanding is the cat simultaneously alive and dead, and I see no reason why we should think that's the case. There's no reason for us to assume that it is the observation of an individual human being, of an actual mind, that causes the collapse of the waveform. And even if we did, I would think the cat's observation of its own life and or continuing death would suffice to collapse it. And of course, Everett's interpretation is a horse of an entirely different color. In which case, there would be probably an infinity of universes, but roughly half of them and half of infinity, which makes a certain kind of sense if you think about it, in which the bomb does not explode and or the cat lives, and another 50% in which the bomb explodes and or the cat dies. And there's that. So that's really all I've got for you on this discussion, but it was an interesting thought experiment, and I just thought I would take some time to give you my thoughts to that. Peace.